Hey guys, welcome to this video. In this video, we'll be solving a very important and a very popular question, I would say. So it's the Max Sum Contiguous Subarray. This question is kind of available on all the coding platforms, but I'm going to go ahead with Interviewbit. So let's jump to the question. So given an array, let's take this array for an example. So what we'll have to do is we'll have to return the maximum sum possible by taking in a contiguous subarray. A contiguous subarray as in an array, a subarray of contiguous elements, as in you take in any set of elements of the array which are adjacent to each other, one after another. So if you take this array for example, so basically we have 1, 2, 3, 4 and minus 10. So if you take in this part of the subarray, it sums up to 10, and including the minus 10 it would end up in 0, so we don't do that. So basically 1, 2, 3, 4 summing them up will give us 10. So that's basically what we'll have to do in this question. I'm going to the next example. You can see that if we take in this subarray, 4 plus minus 1 plus 2 plus 1, it gives us 6. So basically we'll have to find the subarray which gives us the maximum possible sum, and subarray, by subarray I mean adjacent elements of an array. So yeah, let's go ahead into solving this question. So basically, like taking in the second example from the Interviewbit examples itself. So how we go about solving this question is we take in two variables. So the first one we'll have to assign it to minus infinite as in the largest possible negative number that can be stored into an integer value would do fine, integer variable. And then the other variable you'll have to initialize it to 0. So what these two variables are for are so basically a would be the variable that holds the maximum possible sum found so far, like as in we iterate through from the beginning of the array till the end of the array, and then a will be the maximum possible sum that has been found so far, and b will be the sum that we find at each possible iteration or each possible subarray, we can say. So every time we find that the new subarray, the sum of the new possible subarray is greater than the previously found one, so found so far, we'll assign a to that. And so basically by the end of the iteration we'll have the maximum possible sum array in the value a, in the variable a, and we return the variable a. So this algorithm put up here on the left, left. So sorry for that. Put up here on the left is called Kadane's algorithm or Kadane's algorithm. I'm really not sure how you pronounce his name. Sorry on that. So going ahead with this algorithm, so initially, as you can see, that the value of b is 0. So every time we traverse to the array from the 0th element till the end of the array. So we add the ith element of the array at the ith iteration. So initially, since I is 0 now at the beginning, so a of I will be minus 2. We add minus 2 to 0. So we add minus 2 to 0, and b's value becomes minus 2. Now a being minus infinite is obviously lesser than b. So a is equal to b. So a is equal to minus 2 right now. So this is the description there. A is equal to minus 2, and since b is less than 0, we assign b to 0. So why we do this is, why we assign b less than 0, why we have this step here is this if statement is, as in like if there are we don't really need negative numbers summing up. So if I have minus 2 and minus 5 here, there is no point of me summing it up because we want a maximum possible sum subarray, maximum positive sum. By adding negative numbers, it's just going to decrease our sum value, and so that's not really what we need. So we're just going to assign it, we are going to assign b is equal to 0 for the next sum. So but if it's positive, we're going to continue with that because adding up positive numbers is what we want. So yeah, so going ahead with the description of how going ahead with the traversing, what we have is at the first iteration, as I explained, a will end up being minus 2, and b, since it's negative, will end up at 0 at the end of the iteration. Then the next element at I is equal to 1, we have a of I is equal to 1. So b being 0, 0 plus 1 will give us 1, and then a is initially minus 2 now, and b being 1, since minus 2 is less than 1, we assign a is equal to 1, and since b is greater than 0, we don't set it back to 0, so b remains as it is. So going ahead with this algorithm, we end up with a is equal to 6, that is adding up 4, minus 1, 2 and 1. and we'll return whatever's the value at the end of the iteration. So since a is 6, we return 6 or we return a. So, and one more very important thing is we have to ensure that a is not assigned to 0. A is always assigned to minus negative of the maximum possible negative number that an integer variable can hold. So why this is necessary is because let's say we assign the value a is equal to 0, and yeah, see, suppose if we make the mistake of assigning a is equal to 0 and we have an array where all the numbers are negative, let's say minus 2, minus 1, minus 3, minus 4, minus 5, minus 6, minus 5. But if you see in this algorithm, if you take a is equal to 0, a here initially b is 0, so b plus a of 5 will be b is equal to minus 2. Now is a less than minus 2? No. So a will continue to remain 0 throughout the iteration, and at the end of the array we'll end up returning that the maximum possible sum is 0, which is a wrong answer because neither there's a positive number and nor there is the number 0 in the array. So there's no possible way of 0 being the maximum possible sum, and that's definitely the wrong answer. And so we shouldn't make the mistake of assigning a is equal to 0. So a always has to be minus infinity or minus maximum negative integer. So yeah, let's move it to the coding part. So I'll just go ahead and code this really simple question. So yeah, I'll be using Java. You can feel free to use any language you want. So first, let me go ahead and find the size of the array, and then I assign a is equal to, this should be somewhat equivalent to, the negative infinity I was talking about. So now I iterate through the array. So first I assign I check if the maximum sum found so far is lesser than the current sum of the subarray, and if the current sum of the subarray is less than 0, I initialize b to 0, and then I return a. Yeah, I guess this should do the trick. Let's see. Yeah, compiled successfully. Let's submit. Yeah, great. So it passed all test cases. Yeah. Oh yeah, and a very an important thing we can note here is a couple of years ago when I first came across this question, I made this really silly mistake of thinking that why don't we just add up all the positive numbers, like maximum positive numbers, and just ignore the negative ones. If we go ahead and do that, make that mistake, we can see here that the positive numbers are 3, 5 and 4. So since 3 is, the adjacent numbers to 3 are both negative, here the maximum sum of the subarray will just be 3, but here if you go ahead we'll have 5 and 4, so it will be 9. So going ahead with that logic, we would think that 9 is the answer, but if you actually think of it, this entire subarray will give us 3 plus minus 1 plus 5 plus 4, which would end up being 11, and that is actually the maximum sum of the subarray and maximum sum of the contiguous subarray that's asked in the question. So yeah, don't make the silly mistake of assuming that we can just add up the positive numbers and ignore the negative ones. That's definitely wrong, and yeah, I'm pretty sure none of you guys would do that, but I kind of did that a couple of years ago, and yeah, let's not do that. So yeah, that's it from this video, and I hope you guys learned something out of this. Thank you.